Okay, welcome to part two. This is where we left off, talking about squaring a binomial. And just wanted to put it into general terms again, that if you have x plus a, then that's going to, quantity squared, then that's going to equal x squared plus 2ax plus a squared. That's the general pattern. Sometimes you see it with a and b or x and y. For some reason, I felt like mixing it around and going with x and a. So that's the general pattern. So it basically means you take the first term and square it, take the two terms, multiply them together, double it, and then the last term is the last term squared. So let's practice it once. X plus 7, quantity squared. If I'm following the pattern, I take the first term and I square it. Then I take the two terms, multiply them together, 7 times x, and I double it, and it's going to be positive. So let's multiply the two terms together and double it. That's the 2ax. And then the last term is going to be take the second term and square it. So let me clean this up a little bit. So I get x squared plus 14x plus 49. And if you don't believe me, go ahead and put me on pause and actually multiply out x plus 7 times x plus 7 and see what you get. I think you'll get the same thing. Alright, moving on. Oh, a plus b, quantity squared. See if you remember the pattern. Write it down now. Put me on pause at the same time. Okay, since I have capital letters in my problem, I'm going to use capital letters. So square the first, multiply the two together and double it, and then square the last. A squared plus 2ab plus b squared. Okay, well here's a different one. This is what we call the sum and the difference of two terms. Notice that the a and the b here are the same as the a and the b here. The a and the b will be known as the two terms, term 1, term 2. Here is the sum of the two terms. Here is the difference of the two terms. We call this the sum and difference of two terms. And if we multiply it out, we end up with a squared plus ab, oh, I did it backwards, but you stay with me, minus ab, and then minus b squared. And if I combine my like terms, the plus ab and the minus ab cancel out. And what I end up with is the first term squared minus the second term squared. And we call this the difference of two squares. That's what this is known as. So when you multiply the sum and difference of the same two terms, it results in the difference of the square of those two terms, the difference of two squares. So let's see if we can use that pattern on a really, really hard one it looks like we're starting out with. Okay, but if we use the pattern, it won't be that hard. So all I do is I take the first term and I'll square it. And then from that, I'll subtract the second term squared. And so this is what it looks like. And after a little cleaning up, we'll end up with the final answer, which will be the difference of two squares. So this is 25, because that's 5 squared. X squared squared is x to the fourth. Y squared is y squared. Minus, and then we all know 11 squared is 121. So here is my final answer using the pattern for the sum and difference of the same two terms. It equals the first term squared minus the second term squared. Clean it up and write it as a final answer. And then I believe this is lastly, so this video hopefully isn't going to be a 15-minute or so altogether. Maybe it's only like 25 minutes, so not too bad. Here we have the quantity a plus b cubed. So if I'm doing this out by hand, that's a plus b times a plus b times a plus b. Now you can't do all three at one time for those of you who just like to whip through your work. And yes, I'm looking at you, Justin. Anyway, I have to do it just two at a time. So I have to figure out which two do I want to concentrate on. So I'm just going to concentrate on these first two. Once I'm done multiplying these first two together, then I'll take that product and multiply it by the a plus b binomial over here. So let's go ahead and do this multiplying. A plus b times a plus b, that follows our a squared plus 2ab plus b squared pattern. I hope you remembered that. Now I need to take that and multiply it by this a plus b here. Okay, so I'm just going to do the distributive property over and over again. This is very similar to the very first problem we did in the first video. So I'm going to take, I like to do the smaller binomial times the bigger trinomial, but it really honestly doesn't matter because multiplication is commutative. But I get a times a squared is a cubed. A times 2ab gives me 2a squared b. And then if I do a times b squared, I end up with a b squared. I don't know why that lit up like that. And now if I do, let's go here. I don't know what color these are. Now I take the b and I'm going to multiply that by each term. So b times a squared is a squared b. Hey, I already have an a squared b down here. I'm going to line up this one a squared b with the other a squared b I had, so then when I combine my like terms, I'll just combine straight down instead of doing it all horizontally. Let's see what I get next. B times 2ab, that's 2ab squared. Aha, there's another ab squared, so I'm just going to write it down here. 2ab squared. And then lastly, b times b squared gives me a nice quaint b cubed. Almost missed that one. Now I'm just going to add straight down. Add straight down. And so a cubed stays a cubed plus 2a squared b plus 1a squared b gives me 3a squared b. And the same thing over here, but 3ab squared. And lastly, b cubed. And you can see here I have my final answer as this 4-term polynomial. 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Notice the degree of each of these 4 terms. What's the degree of each of these 4 terms? They all have the same degree. They all have a degree of 3. Okay. Notice something else about the variables here. I have a cubed, a squared, a to the first, and then technically over here I have a to the 0, if you want to think about it that way, because a to the 0, just like anything to the 0, equals 1. And now look going backwards. B cubed, b squared, b to the first, and then over here, technically I have b to the 0 if I want to think of it that way. So notice how the variables go 3, 2, 1, 0 and 0, 1, 2, 3. And pay attention to the coefficients now. 1, 3, 3, 1. There's a pattern there which will hold true for all binomials being cubed. I don't have a practice one, so let me put a practice one here. Let's go x plus 4 cubed. We already know what x plus 4 squared is. So we know that this is going to become x squared plus 8x plus 16. And I have to multiply that by x plus 4. You go ahead and FOIL that out if you want. You take your time doing that. I am going to take my time doing the pattern. The pattern here says take the first term, cube it. Then it says do the coefficient 3 times the first term squared and the second term to the first power plus coefficient of 3, then the first term to the first power and the second term squared. That square should probably be on the outside. Squared. And then lastly, coefficient of 1, the first term to the 0 power, and the second term cubed. So now if I clean this up, and wait before I do, I have 1x cubed, 4 to the 0, plus 3x squared, 4 to the 1, plus 3x to the 1, 4 to the square, plus 1, x to the 0, 4 to the 3. So the pattern tells me I end up with x cubed See, 4 to the first is 4 times 3, 12x squared. 4 squared is 16 times 3 is 48. And then plus 4 cubed, 4 times 4 times 4, 4 times 16. And that gets me 64 right there. So if I follow the pattern, this is what I get. Should have been the same thing that you got when you did the distribution. Well, this is it. We get an opportunity to practice it now in your book assignment, so I hope all is going well. And again, sorry for leaving you for these 2 days, but I'll be back tomorrow to catch us all up and figure out what's going on. Thanks again, and see you later.